Okay, ordinary differential equation. So you've got to sort out the following one. Y prime is equal to x plus 5 times y plus 3. So we want to end up here with y is equal to stuff with x and a c in there as well somewhere. So I'm going to rewrite it first anyway, as y prime is dy dx equals x plus 5 times y plus 3. So we always try and just to get rid of our dy dx, we just try to integrate straight away. Then you notice you can't integrate because you got y's here as well, so it's not a simple straight up integration. So we'll try and separate them, and we can do that easily enough here. So we want to get our y's with our y's and our x's with our x's. So I'll notice here that the dx is dividing, so when it comes across it'll multiply, and then this y plus 3 is multiplying the x plus 5, so when it comes over it will divide. So the dy on the left hand side is staying where it is, y plus 3 is multiplying, so when it comes over it divides, and where dx is dividing it comes over it multiplies. So x plus 5 multiplied times dx. Now I've got my y's with my dy's and my x's with my dx's, so I'm ready to go. So the right side is easy enough. So when I try and integrate both, I notice that the left side's a little bit weird, so I'll just do the left side over here. So I've got dy over y plus 3. So it's not a normal simple integral. So what I'm going to do is I'm going to use substitution here. We can use substitution or parts, and we always try and use substitution first. So I'm going to let u equals y plus 3. Okay, so I get du dy equals 1. So du is equal to dy. So I can swap my du for my dy, and I can swap my y plus 3 for u. So I know dy is the same as saying du, and then instead of y plus u 3 I can just do u. So I'm just getting the integral of u then, and then when I look up the integral of u, more correctly the integral of 1 over u, it's going to give me the natural log of u. So the natural log of u. Okay, so I've got my plus c there, but I'm going to hold on my plus c to all my plus c's till the very end anyway. So my natural log of u, and in this case my u is y plus 3. So natural log of y plus 3. Okay, now we're ready to put this back together. So on the left hand side here, through my substitution, I can see that the integral of that is just the natural log of y plus 3. And on the right hand side, x squared over 2 and plus 5x. And I'm just going to still keep my c till I have everything kind of sorted out a bit more till I'm ready to go. So I need to remind myself now how a log works. So the basis of how a log works is if I had the following. Log 8 base 2 is equal to 3. Why does that work? Well, basically it means 2 to the power of 3 is equal to 8. So I can rewrite that as 8 equals 2 to the power of 3. Now it's the same thing here, except that when I see ln, that is log base e. So if I had, let's say, log base 8 log base e equals, even better again, if I had log x base e equals 5, so e to the power of 5 equals x. So I can say x is equal to e to the power of 5. And that's what we're going to utilize here. So we have our integral done. I'm going to throw in my plus c. I'm going to rewrite my ln just as log base e. So log base e of y plus 3 equals x squared over 2 plus 5x plus c. Okay, now I've got my absolute value signs here, which means positive and negative, but you for this log there's nothing you can put e to the power of to get a negative number, so it'll always be positive in this case. It won't be a valid answer unless it is positive. So we can just have that as just y plus 3, just regular y plus 3. Okay, and we're ready to go. So e to the power of this equals this. So I can say y plus 3 equals e to the power of x squared over 2 plus 5x plus c. And then finally, y is equal to e to the power of x squared over 2 plus 5x plus c. My plus 3 comes over and I get minus 3 here at the bottom. Okay, that minus 3 is not part of your power.